Okay, so we're going to keep on going, and we're actually going to move to some different data types. We're going to work with some raster data, right? We're going to do some raster stuff. We're actually going to open our raster data set that I'm going to use for all the hydrology stuff. And we're going to try to experiment a little bit. I'm going to give you some time to get your hands dirty with that, experiment with that. Then we'll go back, and then I'll show you how to do some other things. But I want you to experiment with that. So I'm going to give you like 20 minutes, half an hour, something like that. So let's go to our, let's open a new project. Let's go to our data set. And it should be in no data. The one called no data, that's the one we're going to use. Okay. Let's make it easier. Don't worry about that. It's like I'm going to make it easier for you. Let's just load the one called actually hydro. Right? This one I haven't read. From hydrology. Should just have that. Right? Okay, you see that? Probably you're familiar with that DM, right? You should, at least. Yeah, whatever. Cancel. Remember that? That I showed on the presentation, right? Yeah. So that's it, right? It's the same DM. This one is this one, right? Okay, now you do it. Okay, I'll give you 10 or 15 minutes. Try to do it. Just like try to do it. Even if you cannot do anything, just try to recreate that. Just like try to find your way in processing. No. It's fine if you don't do it, right? I'm going to explain you how to do it, but I want you to try before. Okay, we're going to first calculate the hillshade and then calculate the contour lines. That means we have to generate vector layers and raster layers, right? So we are taking a raster layer and generating another raster. We're taking a raster layer and generating a vector one, right? That's two things. So we go back to here. Let me take this away. So that's the layer. First thing to do, hillshading, right? We just do the hillshading. Easy. Hillshade up. Okay, just hillshade. Okay. The analytical hillshading, it is in there. Right? Well, you can put the parameters that you want in this case. The parameters just affect the way it looks. Like to do this hillshading, to do a shade, you actually need a source of light. So you can put your light where, in this case, the sun. You can select where you want the sun to be. You know, up at the horizon is like azimuth and declination. You can do like relief exaggeration, so it looks like more like sharper than it actually is. But we can leave it like that. There's no need to do that. The shading method, that's not important in this case, right? You know, this is a purely visual thing. So this is one of these algorithms that is not like in the kriging that you have to know what is going on to make sure that the result is correct. Here, what we want is just something visual. So if it looks good, it's actually correct. But this is a rare exception, right? But in this case, we want something to look beautiful, actually, because the only thing we want is this hillshade effect, right? So it's going to generate a raster layer. I've seen that some of you have calculated that without problems. So that's it. Now I get it, right? Well, actually, with my values, it doesn't look very nice, so I'm going to change those values, actually. I think I can take this away. Let me check if I can put some. It looks much better that way. Right. So there it is. And I have my hillshade. So that's like, you know, give me this sensation of really like the terrain, right? It's like you have a paper and you fold your paper and you say like that. It's much nicer, right? So now I go to my detail elevation model. And what I have to do is to style it actually. So I select this single band pseudo color, and I just can take some color that looks more like a terrain, whatever I can select. There's a plugin actually, in case it's not installed here, but there's a plugin, a QGIS plugin that allows you to use a lot of different color ramps. There's like a very cool one with predefined color ramps. I don't remember how it's called. I don't have it here, but just let me show you in case you're interested in that. Color ramp manager. That's it. It's a very good thing. You're going to add, to style a layer. It has like very good predefined palettes and things like that, and it's pretty recommendable actually. I'm not gonna use it, but just so you know, if you want to do serious styling, that's a must. Okay, I go back to this layer actually. I just do something simple by now. Yeah, that's it. Basically, there's nothing really fancy. Okay, whatever, we have it in here. It's fine anyway, right? We just need a color ramp. We can work on that for a bit more. Right, so we have that now. And then how to combine that with the analytical hill shading? Well, it's like we have two raster layers. If you put one on top of the other, you don't see the one that is below, right? But you can use transparency. So that's the way of doing that. I go to my hill shading, and it just transparency. I just put it like, let's say 50%, right? Yep.
You can also use the multiplier window
Yeah, you can use it. There's a multiplier. Yeah, actually, like there are many different ways of doing the thing. The good thing about it in here, like we're going to deal with the no data values after that. You can just take away, not in this case, but you have like a mask, and you can just also check in there. But like, there are like many different ways of doing it. Yeah, but that's sort of those new modes and the rendering modes, the multiplier, right? They're really cool. There are some examples of you doing, if you're interested in that, making a map that looks like an old map, and you just take like a scanned piece of paper, a full paper, and then you can put it on underneath and make a map that looks like really like an old map. You can do that with QGIS, and this is one of the great things that were added on 2.0 actually. Okay, so actually apply that. It should, okay, yeah, that's an. So actually you see more, you see the colors, but you get the relief, right? And now we put the control lines. And let's look for them. Control lines from grid. You see there's a model in here. We'll go to models later. You see there's several things. Contour from Goodall, contours from grass. We're working with Saga. We know that Saga is correctly installed, so we're going to use that one. So this is a matter of selecting the distance between the control lines. 100 meters. I think it's the same one that is used in my example layer in there. So that should be fine. I just take my, the DM. Don't take the hill shading, because then it's going to create control lines of the shading reflectance, which makes no sense at all. Just select the DM. So control lines of elevation, right? Turn that, and that should be right. And then you can style your layers if you want. You can just put them in black or whatever. Maybe increase this. No, that's gonna be too much. That's it. Yeah, whatever. It's a matter of styling. Then you work on that actually. Right, so you see we get to that by doing some analysis, and we've been using Saga from QGIS, right? So most of the people got one of the steps at least. Some people got the two steps. Some people got like the hill shade. Some of the people did the contours. Some of the people were fighting with the transparency or whatever. But you get the idea, and you see that all the algorithms are very similar. Like, what do I want to do? Hill shades. So you just search in there, hill shade. You find the algorithm, you click on it. The interface is very similar from one algorithm to another. So should be easy to understand what it's doing. Just taking some layers, some parameters, generate some output. Shouldn't be difficult to understand, right? Okay, so we're going to move to probably the most flexible, useful, fantastic, and wonderful module of the whole processing, which is the raster calculator, right? It's very flexible. It allows us to do a lot of things. Actually, some of the algorithms that we have in Saga or in other parts of processing, the things that they do, they're very simple. Like they do one thing, but they can be done with the calculator because the calculator is super flexible, right? It basically allows us to perform algebraic operations on raster layers, right? So we're going to open a different project now. It's a project in the folder called No Data, the one that I tried to open before, nodata.qgis, right? I have a couple of raster layers. One of them, you should be familiar with it. See that it looks different because the projection is different, right? So QGIS is reprojecting on the fly. Now it looks a little bit skewed like that, but it's the same layer that we've been using. And then there's a small one with a watershed and some information. It's the slope, actually the slope in the watershed. And we're going to use that as well, right? So we're going to learn about the raster calculator. I'm going to give you a couple of basic ideas, basic examples. We're going to learn about something called no data values. Anyone heard of that before? Who hasn't heard about no data values? You never, you don't hear about it. Okay, the basic idea about a no data value is that when you take a raster layer, imagine that you take a picture with your digital camera, it's always a rectangle, right? But things in nature don't have that shape, right? So this is my watershed, right? Let me turn off the other layer. So this is my flow accumulation in here, right? So this watershed doesn't have the shape of a rectangle, right? So the raster layer that I use, it's actually a rectangle, right? But there's empty spaces in here, like, the value is the flow accumulation. Don't worry if you don't know what that is. We're going to go through that later, tomorrow. And the flow accumulation only has sense within the watershed, not outside, right? So there's I don't know the data in there. There's no data, but I have to put something because I must have a rectangle, like a matrix of pixels, right? So what we do is you just take an arbitrary value and we use it. We just put a value that, it doesn't mean that that's the real value. If we use the value -1, it doesn't mean that the flow accumulation is -1. That doesn't mean anything. It means that -1 means no data, right? And there's a special type of data because it's data that when we later go to processing, when we do some processing, it's not going to use it. It's going to ignore it, right? It's like, okay, I don't know what is here. It makes no sense to compute things here, right? In the same way, when you render that in QGIS, it's not going to paint anything. It's going to leave it transparent, right? Because there's no data. That means that there's a value, but the value doesn't mean anything. I don't have to turn that value into a color and paint it. It's just empty, right? So that's the reason why you see that. You can see through in here, but in here doesn't mean that this layer, the ACK flow layer, doesn't have values. There are values in here, but there's a value that means that there's no data, right? So that's the idea of no data, and we're going to use that to create masks, which is a very useful thing, actually, right? So let's go and do something with the raster calculator. I'm sure that you can find it in here. Let's do the slope layer. Sorry, let's do the TM. Oh, sorry, no, my slope. Calculator. Right. There are quite a few calculators. There are things called calculate, whatever. I haven't filtered that correctly. Let me calculator, no calculator. Right. You have a field calculator that you can use to create new fields in a vector layer. We have a raster calculator for raster layers, and the same coming from grass, but we are going to use the one coming from Stacker, right? So this is tricky to use because the syntax is a little bit tricky. But then, as I say, it's very, very flexible, and we are going to be able to do a lot of things. So just click on the raster calculator, and we are going to see the interface, which is the one that you already know. Once again, everything looks similar, but there's a new type of parameter. We have been using raster layers and vector layers, but we're using like 1, or maybe 2, like 1 and 1, like a fixed number, right? But here's like, give me a bunch of raster layers. It might be 1, might be 0 in some cases, might be 100. It just wants some raster layers. And in this case, we have this new type of entry that we call the multiple input, right? It's multiple input, it's several layers, but not fixed. It can be 0, 1, 2, 3, 100, whatever, right? So in this case, you just can click on this and you select the layers that you want, right? So in the case of the calculator, I can do operations like multiplying one layer by another. So let's say I want to multiply the detail elevation model by the slope. It doesn't mean anything, meaning elevation multiplied by slope, but if you want to multiply those two layers, those are the layers that I'm going to use, then I select them in here, right? I go in here, I click on here, and I just select them, right? I select the ones that I want, they're selected, you click on OK, it's like 2 elements selected, right? That's it. So the first thing you have to do is select the layers that you want to use, right? First layer starting from up, the ones you select is called A. The next one is going to call B, C, and so on, right? So each one of the layers has a letter A, B, C, D, E, F, G, right? So if I select arc flow and slope, arc flow will be A, slope will be B. I want to multiply them, I said put A multiplied by B, right? That's the way to select. So that's the tricky thing about the syntax. You just select the list of layers, and starting from the first one, it's A, B, C, and it goes on. Yeah. Saga is a monoband thing. Saga doesn't handle multi-band. So if you are going to use that, if you have a TIFF, you have to split it some other ways. It has to be splitted. If there's an RGB image, you can actually go in here and use a split RGB band, and this is going to split it like it's a normal image. If you have like a multi-band thing, like an actual 100 bands, you have to do it some other way. Probably exporting from QGIS. There's no way of doing that in processing. It's a good question actually. It only uses the first one because Saga, it's a single. If you're going to do some other things with the grass calculator or some grass stuff, it might be able to handle that. But if you're working in Saga, it's just single band, right? That's it. There's no. Saga is more targeted at doing terrain analysis, things like that. You use a raster layer that has one band with a single value, temperature, elevation, whatever. It's not really good for doing image analysis. If you're actually going to do image analysis, you should go to our FIO toolbox. That's the tool I'm not going to use it during the course, but this is a library it's kind of an AirDAS, but open source AirDAS, if you are familiar with AirDAS. So kind of that. So if you're going to do image analysis, then you should go to your FIO toolbox, right? Okay. So that's the idea. You select your layers, and then you enter the formula, and the formula has to refer to those layers, right? A, B, C, right? Whatever.
Why do you have 100 layers? What is the indexing?
Then you can use G1, G2, G3, and G. There are two things, like whether you use the alphabet or you refer to layers like G1, G2, G3, and so on. So if you have more than 20.
Are you the one deciding?
No, you can use both of them. I mean, Saga will understand both of them, actually. Yeah. So if you select 2 and it's like A plus B is the same as G1 plus G2. So this is a layer. This is an idea that we're going to discuss tomorrow. When you have a detail elevation model and you're working with the hydrology, there's a way of knowing how much water comes to each pixel, right? To each cell in the DM. And how do I do that? I just take my detail elevation model and I just imagine like if I drop water in here, it's going to follow whatever way. I know because I have the elevation, so I know how water is going to move, right? So then I do that for every single point, and then I think, okay, if I drop water in here, it passes through here. If I drop water in here, it passes through this same point. And then I count how many points are going to end up here, right? So it's like, if I put, actually, in that point, this watershed means that all the water that falls in here is going to end up in here, right? So if you see this layer, it's not very informative. That's what we were saying. The data is correct, right? You know, the values are correct. But you see, like, if you go to the DM, you see we have values from black to white, and it's like, you can see white, you can see black, but you can see gray, all the values in between. It's like, you know, it's much better distributed. But if you look at this one, it's like black and white. You know, it's a little bit of gray. You can see it in your computer probably closer, but you see that there's not a good, we're not really using pretty well the palette. What happens with that is that we have most of the cells, if you think about how it works in nature, most of the cells, they get the water, but they don't get a lot of water from upstream. This is like, they throw the water away. So a river is not going to pass through this. It's just some water. But there's some specific cells, those the ones that are in the river, actually, they get a lot of water. So if you make a histogram of that, you're going to have a histogram that looks like, most of the values, like 99% of the values in here with very small values of accumulation, and then some other ones in here, and almost nothing in between. So this is not like a normal, nice distribution, right? It's distributed like that. So this is all going to be in black, right? This is a black, and this is the white. And there's almost nothing in between, okay, right? So imagine that we want to show this layer but a little bit better, okay? So we use better the palette. How will you do that? Now just go back to, probably you know it, but before you know it, go back to not special things, not maps, just how will you do that if you have a distribution like that? How do you put it nicely in paper? You have an idea, yeah?
Yeah, by logarithm.
Okay, yeah, it's like logarithm. You use a logarithm, and it's like the typical thing that you draw things in logarithmic paper. This is very old stuff, right? So what can we do here? We can maybe calculate, not just represent the ACC flow, but the logarithm of the flow accumulation. How do you do that? You calculate that. How? With the Raster calculator. So that's up to you to calculate it. There's a method that is called log. There's like log, and then whatever you want to calculate, a log, and between brackets you put the name of the layer you want to use. So we are working with layers, not with single values, with layers instead, and it will apply that to all the elements. Imagine that I'm going to calculate some statistics, right? And well, if you go to processing, you're going to find the statistics. I'm sure that you can do that, like the average value, right? So if I go to my layer, to my DM, and say like, let's calculate the average elevation. That shouldn't be difficult, right? You probably can go to here, look for average, look for statistic for rasters. There's an algorithm. But what happens? It's going to calculate the statistics of this rectangle, right? And it's very strange that you actually are interested in the statistics of a rectangle. You're most likely going to be interested in the average within my community or my country or my watershed, something like that. Not a rectangle. Things are not very rectangular in life, except if you live in the United States, but that's a different thing. So I want to calculate, let's say, the average value of the elevation within this watershed, right? Within this catchment or watershed or whatever, right? So assuming that I have an algorithm to calculate the average of a raster layer, what I would like to do is just use this cookie cutting thing and use this one to cut this one. So I end up with a layer that have just this part, right? Elevation inside and nothing outside, or no data outside. Remember what I told you. So that's something that can be done with the calculator, and it's actually called masking. I'm using a mask. This is going to mask all the values outside, just leave the values inside, right? This is really easy to do with the calculator, not more difficult actually than the two operations that we've been doing. But I just give you a few minutes so you can think about it, try to find out how would you do that, right? How would you do it? And there's one important thing that you have to know before doing that, is that if you have your formula, whatever the formula is, you have your formula that you put in a calculator, you have one layer with values and another layer with values, right? So this is like 1, 2, 3, and 4. This is 1, 2, 3, and the no data value, right? If I combine layers and do some kind of calculation, let's say I sum them, this layer plus this layer, whenever there's a no data value, the result is always going to be a no data value. That means 1 plus 1, 2.2, that works, 3 plus 3, then 4 plus no data, that's no data. And if I do the logarithm of no data, it's no data. If I do multiplying by no data, it's always no data. Because you don't have data, so there's no way you can finish the calculation, right? So that's a property, propriety of this, the characteristic of this no data values that you can use for the mask. Now think about it. You have no data values in here. You have whatever values in here, but they're valid ones. And then you have the derivation model. Now try to come up with a way of cutting the DM with the watershed just using the Raster calculator and using that interesting characteristic of the no data values.
Yeah, a mask.
But how do you do the mask?
How did I do the mask? That's a good question.
So you actually use the grid masking? No, that's like, you're too smart for the graph. No, the idea is just to use the calculator. Oh, God.
Calculator.
You use the calculator?
Yes.
So how you do that?
I was importing the two layers, the catchment layer and the elevation layer,
Yeah.
and gave them the names A and B, and
Yeah.
said A plus B minus B,
A plus B minus B.
because B is the catchment layer,
Uh-huh.
and if there's no B level to
Uh-huh.
the A level,
Uh-huh.
there's also nothing to stop.
Cool. That's an interesting way. I haven't thought of it that way. Okay, so you see that it really gets the idea of like when the no data are involved, you get the thing, and it's a very good idea. What I was going to actually propose is to use this very simple trick, actually. To create a mask, although that's a very good idea, actually, what you did. When you have anything that has the area that you want to mask, let's say that's A, right? You just do A divided by A, right? And then you just get 1 inside and no data outside. So then you can just multiply by anything. That's a real cookie cutting thing. You can just, 1 and no data value, and then you just multiply, and it works better. It's fun. I mean, whatever you do, is the same thing, right? So you have to look for an operation just to mask that. Some people use the grid masking. There's like, actually, I didn't know there was even a grid masking thing in Saya.
So what if A is 0?
If A is 0, 0 divided by 0, it's no data, because you cannot calculate that.
Yeah.
0. No, I mean, if you have the 0 inside, that's not good. But if you have it outside, if you have like 1 and 0, then it's work. Yeah. I mean, that even if you have sometimes you have the like binary mask, like 1 and 0, then if you just want to use the 1 side, which is what we are going to do later, actually. 1 and 0, then you divide and you get 1 and no data, because 0 divided by 0 it's not defined, right? So, okay, that's this thing. We do it all together. Okay, whatever. Do it this way. So I just get A and B, right? So it's like the flow and DM, right? In my case, the yak flow it's above, so I should be B. So it's B divided by B.
Can I see somewhere which one is which?
Not actually, no. You can see it in the modeler. There's actually a modified interface, but not in here. It's just the order in here. You just have to, look at the order. So the first one is A, the second one is B, right?
Okay.
So that's it. It's a good idea to have maybe some place where you could show the name of each one. That's actually a good
Is the
idea.
order they show or the order I click?
Sorry?
Is the order you click them?
No, the order in which they are.
Okay.
Should be. Should be. But for so. I just put them in the other order. Let me take things away, actually. So let's get in here and use A as beam. Select them. Oh, the thing is, actually, they're appearing here in a different order. Actually, that's what might be it. Okay, I know what is happening. I guess that if I change the order in the view, but it doesn't change here, so then it's taking the view order for some reason. So whatever, I just take it like that. Okay, should work. It should, I guess. So let me That's it, right? So I get the result. Now we're going to calculate what I say the statistics of that, right? And now I can go to a module that takes the statistics, and when this module is going to read all the values, and here we have values outside of the watershed basin, right? Actually, we have some values outside there, but it's going to ignore them for the statistics. When there's a no data value, it's going to ignore it. That means that if the no data value is -1 or minus whatever, or whatever value is, it's not going to use it for the statistics, right? It knows it's a no data value, and it's going to compute the statistics just with the thing inside, which is actually what we want. So we go to statistics, and there's raster layer statistics in here, right? Okay. So this is pretty easy, but it shows us one new thing that we haven't seen before. The input layer, that's clear. Input raster layer. No problem with that, right? And the statistic is an output file. But it's not a normal output file like the one we've seen. It's not a vector layer. It's not a raster layer. It's an HTML website. It's an HTML page with information. Like when processing has to generate some kind of text, it's going to generate that text in a small HTML page, right? So in here we can save to a temporary file, or we can enter like myfile.html, right? Whatever. So you have the same options in here. Save to a temporary file, save to a file, or save to a temporary file, right? So it's going to generate a temporary HTML file. And if you go run, you see, you read it, HTML output has been generated, right? Open the result dialog to check it, right? So that means that I have generated a website, but how am I going to show the user a website? Well, there's an inside viewer that we have in processing for viewing that. So I close this, and I go to processing results viewer. And this is going to show me graphics, if there's some kind of graphic like a histograms or things, if there's a web, if there's some text data, it's always going to be there, right? That's it. As you keep on doing things during your working session, it's going to add new things in here, and then you can just click in here and go back to that result, right? When you close, it's going to go away. So if you want to keep it persistently, save it to a real HTML file, not a temporary one. If it's a temporary one, it's the same that with the layers. You close QGIS, it goes away, right? There's a good way of checking the extension actually. We can just go to the result layer. And you see, this is a full extension of the layer. How does it calculate that? And I'm going to show you that as well. So I've put, if you see, I have put 2 layers. I have multiplied 2 layers in case what he did was adding them and addition, subtraction. But I'm just using 2 layers. And I said before, like layers have to match actually, right? Well, that's not actually completely true. They might not match. This one had an extension like that, and the DM had a bigger one. But then it's intelligent enough to make them adjust actually, right? And how does it take the extension of the result? Well, the extension of the result, you can fix it. Like I'm working in this region, so this is the region. Whatever you do, you just end up having things in this region. Or you can set this option in here, processing, options and configuration. And for the case of Saga, this in here, use the mean covering grid for resampling. That's it. So that means that it takes all the layers and it just takes the minimum extension that takes all the layers, right? So in this case, it's more than what we need actually, because we just need the small one, but it's the minimum that takes everyone. Right now we can save it. We could just take that away, and actually we can do that with another process, if I'm not wrong. Just to let you know, no, it's not a processing thing, but if you want to save that to a different extent, you just select the image that you want to export, and in the save as, then you can select the extent, right? And that's the map view extent. So what I can do is just zoom to this part in here. You just zoom to the part that you want, and then you just select, save as, click on the map view extent, and it's going to save just the extension that you have. I mean, I can adjust that more, so I just get the true data. This should be this thing in Saga. I'm not completely sure. Let me check for it. 1 second. Actually, see the Saga 2.1. Just because it's not in here, I can add it. I forgot to add it to QGIS, but actually that's exactly that. Crop to your data, and it takes out all the no data value. So yeah, I remember it, but it's been a long time, 10 years since I wrote that. Yeah. Okay. Yep. So you get the idea more or less of what we're doing with the. You see, the raster calculator is really powerful. We can do a lot of things. We can do masking. We can change the units of a layer. We can do things that only use one layer, like the logarithm, like the change from meters to feet. We can combine several layers, and we can do some other things. Right. So I'm going to propose you the last exercise of the day. Right. Let's see. We have this. We have these 2 layers, the DM and the slope, right? So imagine that you are foresters in here, or some of you, or at least this is a place where you study forestry. And let's say we want to know about the area, right, that is suitable for a given plant to grow. And we know 2 things. Well, suitable for planting a given species, right? And we just know 2 things. One thing is that our there are different ways of doing that, but you can do it with the raster calculator. We know 2 things that we have. Our plant just grows between 1,000 and 1,500 meters, right? That's the elevation where it can grow. And here you have areas up to 2,000 meters, areas around 700 or something like that. So this is the area that our species work, right? But we have to go them and plant it, right? And then if we have a look at this slope layer, I can see the values in that one actually. Let me calculate the statistics. That should be easier, right? For the slope actually. So up. That's the one. Okay, you see the minimum value. That's not in the units. Okay, it's a matter of units. This slope is in radians, so that's very nice for computers, not so nice for humans. So it should be. But well, let's use it in radians, so it's easier, right? I could tell you to convert that to percentage or degrees or whatever. But let's say that it grows between, I don't know. No, let's do it differently. Let's put it more complex. So you calculate me, you get rid of this one. I'm going to give you some more work actually. You get rid of the slope, right? Remove, right? You just have the DM. That's everything that you have. Okay? And I know that my species just grow between 1,000 and 1,500, but I have to go there with my machines to plant these trees, right? And my machine doesn't work if I have something larger than 25%, right? So the slope has to be less than 25%, right? So I'm asking you to tell me where can I plant that? So which areas are between this altitude and have slope of less than 25%? You have to calculate the slope layer. I haven't shown you how to do that, but I guess you can do it now. Just go to Saga, look for slope, you're gonna get it, right? And then you're gonna get 2 layers, DM and slope. And with these 2 layers and the raster calculator, just show me the areas where I can plant that species. Yeah? Where I can go and plant, I can go with my machine. That means that slope is less than 25% and it's between this and this elevation. So I can plant it and it will grow, right? So that's the problem. Now you find the solution to the problem. And actually, you see this is the expression Let me check. So it should be bigger. So that's actually how the expression works. And what I'm saying is, for the first case, is, okay, if this is true, this is basically that, right? Between 100 and 1,000 and 1,500, that means that if I take the absolute value of the difference to the midpoint of that, it should be half of the interval, right? So if this is true, I put a 1. If this is false, I put a no data value. And I create the no data value by using 0 divided by 0. So you see it's like basic syntax of the calculator, but you know, it gets a while maybe to get used or to think with this idea, right? So it's like, if it's within that range, I use 1. If it's within another range, I use no data, right? Okay, so now you can try that, and it's not part of the exercise, but then you can try that part. This is what I'm coming up with this I'm improvising. So you get the syntax from here. So I give you the solution to this first problem. Now you use the same syntax to do the solution to the second problem, and then you mix them all together, right? And that should be it. If I use one of these QGIS algorithms, QGIS is the one doing the process. So if there's any problem like, I don't know, wrong data or whatever, QGIS knows what's going on. And it can tell you like, hey, I'm having a problem, or processing will tell you. What happens when I'm calling Saga? I don't know what's going on. I just pass whatever to Saga. Saga is going to do its thing, and it might complain, it might not. Okay, so sometimes when you see these, oops, I couldn't calculate that, most of the time means that it's not correctly installed, right? Or there's some kind of issue, some bug in the software. But sometimes it's because your data is not correct. And I'm going to make you an example. I'm going to generate one of these oops windows on purpose, right? So there's a Saga algorithm called create graticle in here. That's going to give me the chance to show you some other new input. So let's create a graticle. That means a grid of lines, right? And I'm going to create one, but I'm going to enter like wrong values. So Saga is not going to be able to do it, right? Right. So pay attention here. So what I do is I can take the extent from a layer, right? Or I can just enter it manually, like, you know, I enter the extent. I enter the extent with the x minimum, x maximum, etc. with the coordinates of the rectangle, and then I select the width, right? So I take this rectangle and the separation between the lines, right? So two interesting things here is one, how do I enter that? I have this, that I can type the text directly, right? If I don't do anything, you know, it uses the mean covering extent of the layers, in case I have layers, but I don't have layers in this case, right? Or I can see in here, other options. Use the extent of the canvas. So that's this extent here, the extent of the view that you see, or the extent of a given layer. So if you click on that, it's going to show you a dialog, and then you select the extent of whatever, the extent of the canvas. Well, voila, that's it, right? So you have the extent of the canvas, right? Another thing that you can do in here with this type of parameter, it's use extent that you select on the canvas. So it goes away, and then you just drag and drop, and it goes up there, right? So it's easy way of doing things, right? And the one is used to mean covering extent. One thing that you can use is do it manually, right? So see that one? It's like 0, 1, 0, 1, pretty easy, right? So that's an easy extent, right? And now I select the division width, the space between the lines. And what happens if I put 2? Okay, it's into 2, right? But basically it's not going to be able to do it. I have a square that is 1, and I'm asking to separate them 2. So it cannot put them inside, right? The distance, the division distance is not correct. So there's no way I can check in processing that this is incorrect, because it's Saga who is going to do the process. So I don't know the requirements of Saga. I just know that on my side, I can ask the user for that. Now I'm going to send that data to Saga, and the algorithm is working fine. But in this case, Saga is going to say, oh, sorry, wrong data. And it's not going to create the layer, right? So if you go that, what's going on in there? Am I missing something? Am I missing it? Okay, I don't need to add that. Sorry. He calls Saga, and Saga crashes. Ooh, that's even more interesting. But anyway, yeah, right. What you're going to see in the end is this: like, you couldn't create. Most of the time is that it's not correctly installed, but make sure that when you see that, it's not always that it's not correctly installed or there's a bug in Saga. Sometimes it might be that your data is not correct, right? What you're passing to Saga, it's not actually correct, right? So I'll give you a couple of minutes to do that, and you just, fight yourself against this a little bit. I will solve this tomorrow as well, and I will just use the calculator a bit more, so don't worry.